Let me know if my screen is caught up at your end.
Yep, we can see it.
All right. Thank you, DK. Today I'm going to be talking about an into tidyverse. Just like tidyverse, it's a play on the word to highlight the time series portion of it. So the TS. So predominantly, there are three packages within this tidyverse universe, if you will. Sybil, a play on the word of Tibble to emphasize time series. Fable, which is a play on forecast and table together as Fable. Feasts as features of time series, and I like the way they came up with this logo for feasts. So that said, these are the three packages that I will be talking about. More focus on Fable. There are other packages like Fable tools that get installed when you install Sybil, Fable, and Feasts. So we'll talk about that in a bit. Okay. If we can only. I am going to try to do justice to kind of unpack or concisely the conference training that was given by Robert Heinemann during the RStudio conference earlier this year. There are about 50 slides. I'm not going to walk through any of those 50, most of the 50 slides, we won't be able to cover it. This is there for those who feel that I'm either too slow or either too fast. And this slide deck is in the GitHub link under my user Srivatsaish. This link is also posted on the Meetup group. So if you're there, and you can follow along on your own computer. Shankar and I were talking a little bit about the technical reference here, which is Heinemann's textbook, Forecasting Principles and Practice. This is where most of the technical reference is coming from, and this book uses R. So you have all the code that goes into this, all the that are behind these packages, well explained in this book. Okay. So that said, we will quickly get into talking about time series. If you're following along in the GitHub, using the repo on GitHub, I took a cue from DK, use the RN package to kind of lock the packages. So thank you, DK, for introducing me to RN. Let's quickly talk about what time series is. Time series is nothing but a numeric vector that has timestamps attached to it. The base R function has an object called TS, right? It has got an object that has facets. One is frequency. You tell what is the beat rate at which your data is collected, or inherent seasonality in your data, or season in your data. And you attach a timestamp to your data here. So this is the basic syntax. I'll just unpack it in a second. Oops. So here I have supplied some random data, 1 to 10, right? And I said my data is collected, at a beat rate of 4 months, 3 months, with a start year of 2020 and starting the first quarter. So base R intelligently figured out that when I set a frequency of 4, and I said I'm starting at year 2020, the first month, it automatically figured things out. It was intelligent, right? So this is how an time series object looks like. So you can see it's basically an vector on this side of the screen. Why is this object important? If you go to any things like any function like ARIMA, which is an forecasting model, it requires your input variable to be an univariate time series, right? Which is an time series object, right? And stats package, if you go to seasonal decomposition of time series using LOES, all those packages and functions need your data to be in a time series format. How often do we get data that way? We almost never get data as vector, right? You're either looking into a database or a table, or somebody's giving you a CSV or an Excel dump of data, right? Something that looks like this data. We'll kind of, I'll load the package before I get too far. Again, these are the package versions that I'm using. Okay, this may be different from what you might have already pre-installed for your other projects. But when you're using this from the Git repo, I think this is the version that RN forces you to use. Okay. So I have downloaded data on Australian tourism that is hosted on Rob Hinman's website. Is my screen big enough for you guys to follow?
Yep.
All right. Okay. If it's annoyingly too big, let me know. Right. This data has 5 columns. Quarter, you see data collected in a quarterly beat rate. So 1st of January and April 1st, right? And there's region, state, purpose of visitors, either they're on business or holiday and so on and so forth. And the number of visitors during this quarter, right? So if I look at the distinct purposes of travel, a business, holiday, others, and visiting, right? So there are 4. And likewise, for state, I'll use Andro. I'm not going to print all the states here. There are 8 states. And in terms of regions, I have 76. Unlike in the US, where you have many states forming a region like a northeast states, Midwestern states, or South states. In Australia, I learned that many regions form a state, right? So like 76 different region, and people are traveling for 4 different purposes. I have 304 combinations of regions and purpose of travel, right? And likewise, I have 80 distinct quarters, which is 20 years of data. So I have 20 times 304. That gives me, 80 times, which is 80 quarters. That gives me 24,320 data points, which is what your data is, okay? So the point is you have 304 unique And if you were to make time series objects for all the 304 time series, look at the number of variables set in global environment and in the R environment. It becomes cumbersome, and it's very difficult to keep track of the variable names and whole 9 yards. That along with having an ability to have the data stacked in the long form and still be able to fit it into the time series data type would be super useful. And that's exactly the problem that Sybil solves. Okay, so how does it do that? For Sybil, you need 3 kinds of inputs. I'll walk you through what those are in a second. You need the index, which is nothing but the time, okay, which is quarter. You need the key. Think of this as your database key field. What column or combination of would identify your data, right? So in this case, region and purpose would uniquely identify a time series, right? So for business, for all the 80 quarters, right, or 20 years, that is a unique time series. So those are the ingredients that are needed to define and stack time series objects, which is just like a tibble. So let's, okay, so you see you have the quarter here as a character, right? I'm using an year quarter function from the Sybil package to convert the character into year quarter. Okay, and key and I'm providing that region, state, and purpose. I don't really need the state, but I'm just putting it in there. Nevertheless, it won't harm. Then I say what my index is. Index is my quarter in time. So that becomes my table. Okay. So if you notice again, so we have 304 unique time series here and collected at a frequency of 1 quarter, right? And we have retained all the 5 columns. Am I making sense?
Yep.
So, and if you notice, this comes up with an Sybil. So now this is a time series table or table. Okay. So Sybil not only gives you a data type to structure your data to fit into other packages that we'll be talking about, like Fable and Feast. It also opens up on visualizing the data. For instance, you have 304 time series. Let's try and visualize them all together. You see, it brought up 304 time series. Looks ugly, but it did it fast, right? And what I also did on purpose is turned off the legend, because it's going to take a while to populate the legend. And it looks like a ggplot, isn't it? So it has an auto plot feature that recognizes the input to that auto plot is a Sybil, and you're wanting to visualize trips variable. So it plops in plot with all the 304 time series. If you were to want to select only a particular time series, like we could do tourism, I can use the filter, right? Like region. I'm gonna cheat here. I'm gonna copy. you can use the tidyverse schema and filter the time series and then simply auto plot it. See, so here you can use the same tidyverse grammar to do filtering selection. There's another, what if your data is not stacked, right? Something to this effect, right? There's another data set called Australian production. And you have just like an XTS object, which is an extensible time series object, which is again a matrix of time series, just like this. You have different columns here tied to time. Now, how do I plot more than one time series here? You could use the tidyverse grammar again. You can use the vars variable to select any two columns or any more than one column, if you will. So you have selected beer and gas, and you can plot them. It puts them in two separate facets, okay? And if you do want to bring them both into one facet, one plot, you can tidyr function pivot longer, and you can say, okay, let the values go into, all these values go into a column called production, and all the column names go into a column called key. So I'll just simply execute this for your, you see, I have just pivoted the white form to a long form. When I did that, it still kept the Sybil format. See that? As long as I don't change the key, or as long as I don't change the index, it is going to keep it that way, right? Now you can plot, again, use the pivoted into a long form, then I've done an auto plot, right? What does this plot tell you? Any observations?
People love to produce beer.
Exactly. I've been telling people that we need more beer than get fossil fuel, right? So apart from, there's this, of course, they are of different scales, right? People like to drink beer, and there's this subtle wiggliness in this portion of this time series that you can barely see, right? If you want to bring that up and amplify that, you can take the log of the data, right? So in order to do that, see in here, my screen, I am going to plug in the log of production into the auto plot right here. It will automatically do the formulation and plot it on the fly. So do that. So you got that. So you're able to see the seasonal wiggliness here. Of course, it amplified the trend a little bit, but you see the feature here that you can do some mathematical operation within the auto plot. So far with me?
Yeah.
All right, thank you. The other things that you could is use the tidyverse dplyr group by functions, right? So I took my Sybil and I grouped the data by state and purpose, okay? Now I am basically taking all the different regions that are within a state and adding all the visitor traffic, right? So I'm taking that and executing that. It still kept the Sybil, if you notice. still kept the symbol, and it kept the state and purpose as key. And what you notice here is if you were doing this in a tibble, you would only get the group by functions. I'll quickly do it to show as an example. As tibble, right? You see how it took the state and purpose and calculated the trips. It did not keep the time in there, right? Now, just because it's a virtue of, it has the virtue of a symbol, it'll automatically keep the timestamps for you, all right? It makes you lazy. You don't have to explicitly call the quarter in here to make a group, right? So that's one of the key features in Sybil. It makes you a little bit lazy. And you can do right now, when you group it by different states, you got the different time series here, right? So, all right. This is not just a cool thing, right? That is a function called GG subseries, right? So as you can see, it's all within the ggplot grammar, right? What a subseries is, it takes the time series data and shows you the within season variability. What I mean by that is, let's quickly execute this guy. As any good programmer, I ignore the warning message, all right? So I've not even paid attention to it. I wish I can pull this up a little bit. Okay. So here, I have quarterly data for 20 years, right? So it is, now I've selected 2 time series. One in the region Gold Coast and Snowy Mountains, travel for the purpose of holidays, right? So I have those 2 time series. And it shows all the Q1 variation from year to year. So from the first year to all the way to the 20th year, so on and so forth, right? You can see the Snowy Mountains have more traffic during the Australian winter, right? And likewise, the Gold Coast seem to have traffic more during the Australian summer, which is from Q1 and Q4, right? So that's something that allows you to explore within season variability. There's another function called GG season. GG season allows you to explore between season variability. Okay? So here, from Q1 to Q2 to Q3 to Q4 across all the years. Again, this package is not free from bugs. You notice it is put in the year 1973 in here. I don't have data going that far from 1973. All right, there's a bug. Yeah, in the version. I did not hide the labels here. I just wanted to bring it up. Though you can use a Band-Aid fix and use your ggplot grammar to hide these things. All right, that's it. Sometimes you have time series data that are not on a constant beat rate. It's not like you would have data the same time or collected at the same frequency. For example, let's look at the New York City bike data. It's now becoming really popular. It's now becoming like the Boston housing data, right? And you see the frequency is some junk number like in microseconds, right? If you're using the earlier version of Sybil's package, if you're using 0.1.1, this the number in the parentheses will be a question mark. Okay. Reason being, it tells you that, hey, the beat rate at which the data is collected is not the same. And two, there are some missing dates in there. So let me show what I'm talking about when I say missing dates. I am going to next take this start time and then lump it into date. Okay. So what I'm going to do is I'm going to, from this data, I'm going to say, okay, on a particular date, how many bikes were rented? All right. Simply, I'm going to make that computation. So what I'm going to do is convert this New York City bikes into a tibble. Then I'm going to mutate the start date as just the date. I'm going to get rid of the time component. All right. And then summarize the number of rows. That'll give me the number of bikes that were rented out for that particular day, right? So here you go. You have start date and the number of bikes that were rented out. Now this is a tibble, right? Because I made it into a tibble. So this guy I made it into a tibble. Now I'm going to flip it back into a symbol. I'm going to execute this portion of the code here. Now I got a symbol and added day frequency. But if you notice, I have a missing day here. My day 5 is missing of January 2018. What would happen if I tried to use any of the GG seasons or any of those functions? I'll comment out my code here a little bit. It doesn't like missing data. Okay. This is a huge drawback, in my opinion. The use cases that I have today at Ryder is warehouses work Monday through Friday. Saturday, Sundays are off, right? And I have within week seasonality, right? So I wouldn't be able to keep the natural form of the data as is. However, it allows me to fill gaps, okay? So there's a function called fill gaps that will allow me to fill the missing dates. Right. So I'm gonna, now it started to work, right? Have you noticed I have set my period to a month, right? There was no, the initial symbol said the frequency is by day, right? Now if I fill gaps, it is going to plug in an NA for that particular date. I can quickly show that. I'll watch. You see that NA right here? So I put in January 5th and plug in an NA. You can make it fill any day that you want, any number that you want. Bikes is equal to 0. Then instead of an NA, it's going to plug in a 0 right here, right? And you can also change from month to maybe a week. See if change the week and it shows, different days of the week here, right here. Okay. One word of caveat. In this repo, if you go in and look up an appendix folder, I think I have an appendix folder. I have compared FPP, which is the tidyverse, versus the time series object. And the effect of fill gaps, right? If you fill gap and run an ARIMA model, if you don't fill gap and let the series play out as is, but use the base package's frequency argument and explicitly say it is 5 days for a business that works Monday through Friday. So you have this argument in, you see this frequency right here, this frequency argument. You can set it up to 5 days and don't bother to fill any gaps, right? I just, on one hand, I filled gaps. On the other hand, I kept it as a time series based model, ran ARIMA models. I got 2 different models with 2 different model accuracies. Fable package gave me a poor accuracy, but time series gave me a better one. So you have to be mindful of what you're doing. Okay, that's the point here. So now let's slowly get into the modeling phase, right? So Sybil has TS display. It's another plotting function. What that does is it gives you the raw time series output as well as the seasonality, the GG season plot. It also gives you what's called an autocorrelation function plot. What each stick in here is the correlation between point at time t and at time t minus 4 in this case, right? And time t minus 2, so on and so forth. Okay. This gives you an indication of how your data is correlated and can feed into your decisions on how you model your ARIMA model, for instance, right? So that said, you also have the ACF plot. There is also something called partial autocorrelation function, right? If you remove the predominant lag and then look at correlations beyond that, so that's the partial autocorrelation function. So basically this takes out the effect of the first order correlation and then tries to see, hey, which is the biggest one, right? So this is the partial autocorrelation function. This comes out to be at 4. Okay. And the other intuitive way for managers to get a sense of autocorrelation is this way, right? So the data point correlated with or plotted against the lag 1 or lag 2, lag 3, lag 4. So lag 4 is like you go four periods back and that becomes your x-axis and your y-axis becomes your response variable, right? So you see that there's more linearity in lag 4 and lag 8 compared to the others. So this is a nice visualization. Okay. So far, what we have seen, we have taken the time to understand the Sybil, what it offers to inspect time series data, right? The next step in the modeling process is, to determine if there are any transformations that are required. Transformation for your data. I'll give you an example here. Let's look at a data called Australian retail. Australian retail has state, industry, and unique time series ID, and the timestamp and the turnover. Okay, so that's how it's arranged. So what I'm doing is I'm filtering on the industry food retailing and just taking out and just summing up the turnover, right? So this is how the data looks. So I made it into a Sybil, okay? And this is how the data looks. You see the seasonal peaks, amplify as the trend increases. You guys are able to see it? In order to make your models fit such behavior well, or fit this time series well, need to make a variance stabilization. Okay, you need to stabilize the variance as your trend increases. You need to make that as a stationary time series. It'll invariably give you a better performance, right? The way you can do that is simply take the log of turnover, right? If you notice, you can do that. It stabilizes the variance by just simply taking the log, right? Now your model performance will be a lot better, right? In some cases, you might have to do an box-Cox transformation. That's where your feast package comes really handy. So this particular function called features has a method called Guerrero. Guerrero gives you the lambda parameter for making the box-Cox. There are other features that you can go explore. If you go search in your RStudio help by features by tag, it gives you all the other available options. Okay. So in this case, I'm just running the box-Cox lambda. Now we have that same thing. Okay. This is my favorite. I use it every day. There is a feature, just like how we did Guerrero, you can do feature underscore STL. STL is nothing but seasonal trend smoothing using lowest filtering or lowest regression, right? Watch what it does. I like it and I use it every day at work. So there are like 304 time series, right? As I mentioned for the Australian tourism data. For all the 304 time series, it kind of collapsed that and gave you a metric for that. For every time series, it has given you like I think nine metrics, 12 minus 3. It has given you seasonal strength, how trending if that time series is, right? It's a score of 0 to 1. I'll give you a quick example here. I'll give you feed underscore STL, and I'll go to the, see, this is, when you decompose time series, you can decompose into 3 components, invariably into 3 components. One is trend, the other is seasonality, and the other thing is remainder, right? So your time series value is equal to trend plus season plus whatever, right? So what the trend strength is this looks like an R squared value, right? How much of, if I take out the trend, how much is left over, right? If there's very little left over, then the trend strength is high. If I take out the seasonality and there's very little left over, then the seasonality strength is high. Am I making sense? Yes? No? Thumbs up? Yeah. Okay. So all the 304 time series are now collapsed into these metrics, right? Now I can, and it makes it into a table. Takes all the 304 time series data, then makes a 304 by 12 table, and it's given me some metrics like trend strength and trend seasonal strength. Now I can plot them just using the ggplot grammar. Now I can say, hey, look at these 2 data points right here. Western Australia, this is high on trend and high on seasonality. Oh, that is something that is interesting. Now you can filter that particular data. I'm going to rush a little bit here. So you can just, by filtering that, you can see what that data is. Okay. You have seasonality and there's this little trend that, that it captured. Now comes the fantastic part if you're into modeling, right? Hands-on modeling. Any modeler would now start to think about, okay, now I've explored the data, now I've made the necessary transformations. Now I have to think about what is my training set, what is going to be my validation and test set, right? We're going to attack fitting the models as well as deciding the training and validation step in a single step, okay? Unlike if you've used forecast package, you would use the window function to separate out the training data, fit the model, then you have to separate out the test data and then compare. It's kind of tedious, right? Here you can do several things at the same time. And if you notice, you have the Sybil. Now I'm filtering out the time series that I need to model, in which case I am filtering on region and the purpose, right? Then I'm selecting year less than 2015 as my training data, okay? Now I'm fitting 3 models at the same time. If you were using forecast package or the base or stats package, you would only be able to fit 1 model at a time, right? Here, you will be able to fit several models at the same time here, right? So seasonal life, which is simply taking the same time last season, what is the value? And I've fitted an autoregressive moving average model, a REMA model. And there is something called exponential trend smoothing model. You could do all of that in one single step. And you can explore that right here. You see, after it is fit, it has come out with something called Mabel. Can you guess what it is? It's model table. Okay. So
I said it, but I was muted. What did I win? No.
You do. Now you can just think of it as a table. Then you can select a particular model and inspect the model parameters. What are the coefficients? You can use the report function. Okay. Now we'll talk about you've fit the model. Now how do you forecast, right? So you pass the model table, Mabel, into a forecast function and say H is equal to forecast horizon. I'm going to predict or forecast for the next 3 years. Watch how 3 years is mentioned, just in plain English terms, 3 years, even though our data is in quarterly terms, right? It figured out that you're asking for the next 12 quarters, all right? And see, you have a Fable forecast table, right? So you look at the contents of the thing. So you have 3 models, right? So right here, 3 models because we fit 3 models. And we fit for 3 years, right? So 12 times 3, 36. So 12 quarters for 3 models, 36 rows. So you got that. Now you would be able to forecast it. Oh, I have to do this. You see how it identified what the data is and made a nice plot. If you notice what I did, I took the forecast from here, right? That's this guy. And I passed in autoplot and passed in the entire Sybil, right? Even though I had only modeled for 1 time series within that entire Sybil. I trained a model for 1 time series there. But I passed in the entire Sybil as an augmented autoplot. It figured out which time series that I had marked and what it needs to plot, it figured out, right? I don't have to do anything. If you were using the forecast package, you had to handle for all those stuff. This makes us a lot more lazier, all right? And finally, how do you inspect your models? You can use the accuracy function. You pass the forecast into an accuracy function and pass in the entire symbol. Watch what happens. It automatically figured which is the test set, which is this region right here, right? It figured out this is the region. It automatically gave you all the different metrics like mean error, RMSE, MAE, mean absolute error, MAPE, all the good stuff. And this probably will remind you of a Broom package, where, you know, Broom package kind of puts together all the model results this way. All right. And if you're like kind of me, doing the examining the residuals, you have the GG residuals as well. I'm going to skip a little bit and talk about what if you had transformed the data, right? If you had in forecast package, you had to transform your data, save it, make forecasts, then that'll give you a transformed forecast. Then you have to untransform it. You have to go through all those steps. Here, it makes us even more lazy. Here, I made log transformations of my response variable right here, which is trips. And watch, I can do just that. It gave me the models. Then if I pass in the entire symbol, oh, how about making a forecast? Forecast H is equal to 3 years. And do that. See, it, you know, it unlogged it or anti-logged it and made the plots. You don't have to handle that. It makes you super lazy. Finally, if you want to make an ensemble of models, if you want to take the average of all the outputs of the 3 models, you can simply pass it in right here. Again, another mutate. You say outputs of season life, ARIMA, and ETS, all in the same block. You do that, and it's done. Okay. And you similarly, I'm not going to go through this check for accuracy. We've done that before. This is another cool feature. Let's say I have a block of model and I want to try 4 or 5 different models for all the 304 time series. I have to pass in the entire symbol, then filter out the training set and simply plop in the model. It'll benchmark it'll fit in all the time series, right? It'll run in parallel, okay? So I'm loading the results of this, which I saved in an R data file. I'm not going to run it. It's going to take a little bit of time, but you have, see, a model or Mabel for all the 300 series right here, which is super awesome. It fit everything. Now you can query whatever model that you require based on your other key columns like region, purpose, and then make a forecast. See, that's what makes it super awesome. I love it. So I don't have to, unlike forecast package, save all the different time series, then fit all the different models, and you just plethora of environment variables. So that'll be a lot to handle. And so similarly, you can do all the accuracy metrics and things like that. And most often I get asked, hey, what about external regressors? We've just looked at only time series as a univariate thing. I'll give you a quick example right here. Here's an data set for US change in consumption as a function of income, production, savings, and unemployment. You can simply fit in a linear regression model with ARIMA errors just by saying, just like how you would feed into a linear regression model, you can do it right here. It automatically does it in the single step. If you were to do it manually, you would fix the ARIMA process parameters, then tune the linear regression coefficients, then come back to your ARIMA errors. So it's kind of seesaw. You have to go both ways to fit an ideal model, which is what I like. And you can also use a time series linear regression model. So you can plop in all the other external regressors, and you can say, I want to include the seasonal effect as well. I want to use the trend effect too. So you notice there's not much due to seasons, but it has taken a lag of year 2, 3, and 4. You can also do Fourier series that is coded in for here for that. Here I'm using an ARIMA model, but forcing the seasonality to be taken care of by the Fourier model and not the ARIMA model. So you can do that. Oops, I didn't initialize Australian Cafe. Yeah. So you can do all those stuff. Here I'm taking a log of the data. You can do all those good stuff. And you can look at the different, you use the glance function from the Broom package, then you can look at different model performance and you can choose the one that you want and inspect it. Okay. So yeah, you're able to forecast for the next few years. That's the material that I have. I know it's a lot that we covered, and hopefully I covered all the modeling process here, exploring time series, transformations, model training, using splitting the data into training and a validation set, and model fitting, and checking against the test data set. So what I've not covered is several that's handled in the book. So, and one other thing that I want to point out is that is in, this presentation, I use several data sets, right? But if you want to follow a single data set over and, use different methods and techniques, I have a project listed here under my GitHub link, US sales forecasting. It's one data, and I've used different modeling techniques and dwelled into the depths of Fable, and, made some more cool stuff in there. So that's all I got.
I have a quick question. I joined in the car, so I couldn't see the screen early on, and I couldn't see the name of the book that you referenced. Can you share that again? Oh, that's it right there. Okay.
Forecasting Principles and Practice. It is a free book. I suggest you look up FPP3. There is FPP1, FPP, FPP2, and FPP3. I suggest that you look at FPP3. That has got the latest and greatest. This package is not perfect. It has got its bugs, and I spent a lot of time getting around the bugs. And the way I did that is in my US sales forecasting repo. If you're interested, I haven't contributed to this package in any way. I think I'm too far behind to do something like that, to open up a source code and make some changes. I haven't done that, but I've gotten around by kind of unpacking some of the internal variables that you can see in this project.
That's really cool. I'm impressed. I like I have, you know, a couple years back played with the forecast package, and I remember trying to figure out how to like just fit a bunch in parallel, and it was kind of tedious. I remember Prophet had some ability to do that. I was kind of like playing with that. I'm by no means a forecasting pro, very much a novice, but have you ever used Prophet for?
That is something that I want to use, and I haven't used it. Unfortunately, I learned that Prophet is not on CAN anymore.
It's back on. It's back on.
Back on?
Yeah. Hattie Wookham made some changes, and it got back on like a month ago or so. It was down for like a couple of weeks. Yeah.
Yeah, I tried to install it and it said it wasn't there, and I looked at the news and said Prophet would be knocked out of CAN. So
yeah,
I haven't used that.
Yeah, I need to go back. I mean, this is an excellent presentation. I need to go back and see, you know, some of the stuff that you did early on because I was just able to listen. But it seemed like there's a lot, you know, some parallels between Prophet and this package. But from what I've seen, it seemed like this package is a little bit more flexible. Like the situation where you show where you can create multiple models at once. That is not something you can do. And then with Prophet, it's more of you know, I would classify it more of like auto machine learning, and that you can tweak some things, but you don't have the amount of flexibility that you have with this package. You pretty much have to go with, you know, their underlying. You don't know what's going on behind the scenes.
Yes.
Whereas with this one, it seems like you can do a lot more.
It's got some flexibility as well, so you can, you know, you can go tweak some parameters and you can tune some parameters.
Yeah, and that Sambo feature that you showed, that was amazing.
Yeah, that blew my mind. Yeah, that blew my mind.
And I like that it's consistent with the rest of the tidyverse syntax.
Exactly,
Plug it in. And personally, I like things that let me be lazy.
What I have not tried is using the DBI package, bring in a lazy table and convert it into Sybil on the fly. Right. So I often interface with SQL tables, and I use the DBI package to write, you know, dplyr type of SQL code and bring in a lazy table and do summarization that way. But I have not tried to see if it would go, you know, make it a Sybil for me. I doubt it, but I haven't tried it.
What's the definition of a lazy table?
In the background, so you're familiar with SSMS, right? SQL standard, SQL Server Management Studio. Yeah. Then you go right click. Yeah, you go to a table, right click, click top, select top 1,000 rows, right? And it gives you the top 1,000 rows. Similar to that, what it does, it gives you a preview of the table, and it executes on the server, not on your R machine, right? Your R server or your laptop, right? It's gonna query some data, and you can pipe, mutate, do all those good stuff, right? In the back end, it's going to convert itself into a SQL code. Then when you say collect or, you know, download the data, it's going to ship the SQL query to the SQL server and have the computation run on that and give you a table. So you're not downloading the raw data, you're not doing the filtering and all those stuff. It happens at the SQL.
Where the power is. Okay.
So when you go type in on your console a table that is not being fully brought back, it'll tell you that for any like empty cars, right? Empty cars is not a sucks. What is in Tibble? I don't know. Tibble data. I don't know if there's any data in here. But anyways, I thought, I'll do this. Empty cars as Tibble, right? So here it tells you the number of rows, 32 times 11 columns, right? in a lazy table, it'll print few rows and put a question mark there. I do not know how many rows are there, but I know the structure of the table. I know the data types. I know what you're trying to do. I have it all in SQL query. I've just not executed it. So I will give you that. That's something that I want to try. If I'm able to make a lazy table into a lazy table, that will meet my use case wonderfully. So I don't have to bring all the 304 or several hundreds of time series into my memory RAM, right? So I can still keep it at bay and SQL Server.
Quick question: are you familiar with SQL Server machine learning services?
I have explored it, not to an extent that I would have liked.
A lot of that stuff. One of the downfalls you have with it is that it uses a earlier version of R, right. So this package probably wouldn't work on it. But a lot of the stuff that you mentioned, it has built-in functionality that allows you to do that. You can either run the same code right. that you have here, just refactor a little bit and run on the server, or they have special functions that was developed by a company called RevelScalar, who was acquired by Microsoft, that allows you to process big data in chunks. So it's pretty, and that's one of the features that you mentioned that got me thinking about a lot of things, like the feature you showed earlier where you can generate multiple models at once. Well, those models can be saved in a SQL Server table as an object.
That's right.
You can within a, from a R store procedure. So, man, I can see a lot of great things being done with this package in combination with SQL Server.
Right. I'm not sure how this plays into Azure Data Factory. My data engineers are pushing me into, plopping my models into the workflow there. Model outputs.
I wouldn't use Data Factory. In that case, if you want to go to Azure, I would use Databricks. You probably can use Data Factory for the workflow, but Databricks would be either Databricks or Azure Machine Learning Services. Those are the two places where, Data Factory, the only thing that's used for is for data movement. But in terms of the modeling, you can do that in either Databricks, and you can use R Databricks or Azure Machine Learning Services. R became a part of Azure Machine Learning Services just a few months ago. So
yes. And the RevelScalar was, I used to work for Cummins before I moved to Ryder, and we used RevelScalar for a little bit until we had our own R server, right? R Studio, R server. RevelScalar was, the syntax were different, it was like not, it was a little frustrating to, get errors to things that you already think that right? I need to move past really fast, and you're like, it's like walking on carpet with Velcro shoes. Get stuck every time.
But there were some features, like a lot of the stuff, with RevelScalar, you can actually leverage, traditional R packages as well. So if you would have got a little deeper into it, you probably would have, there probably been some things that you would like. But the focus now, Microsoft has moved away from wanted to do things in the database where they want to use, if you're going to Azure, they want you to use Azure Databricks, they want you to use Azure Machine Learning Services. And like I said, R is a part of that right now. So a lot of stuff that you're doing right now, it can be done refactored in either Databricks or Azure Machine Learning Services. And with Databricks, one of the benefits you get is I have the brain fart right now, where you do computations on multiple computers. What is that called?
Scaling or
when it scales out, But there's a lot of features that with DeepWire, they have Spark VR that allows you to do that same kind of
one thing that I heard, Michel Haray, who's the author of this package along with Heinemann, if you execute in a cluster of computers, it knows that it is in a cluster. It can use all the parallel computation.
It will still work? Wow.
Yes.
Wow, that's big. That's big. As Donald Trump says, bigly.
Yeah. Yeah. In fact,
That's bigly.
in fact,
Man, that's
let
bigly.
me see if I can um, demo that part to you right here. Right. So here, my understanding is I'm running it for all the models. I mean, all the time series. Oh, I've turned off the messaging. Usually it gives me that how you would do the Spark queries, that it gives you that little arrow mark going this way.
Mhm.
It does that. I've turned off my message in this chunk. So that's probably why I'm not seeing it.
Yeah.
Because of the YAML. Oh, by the way, the YAML I stole it from Max Kuhn, Dr. Max Kuhn, right? I can if you think my slides are super good, no, it's Max Kuhn's doing. I just changed a little bit here and there. I stole it. If you think it's bad, it's his problem.
If it's good, you know, take it.
Yeah. So. And what I liked about way of markdowns is telling which package is the dominant package here. Right? If I'm using pivot wider here, I would put in a tidyr sticker in here. So this way, people are like, okay, this uses tidyr lubricate. Right? So I kind of tried to use his method of putting a slide deck together.
Is that from like a special package or something to get the hexes? That's what those IA hexes mean then, huh?
No, it's an internal function in the markdown that if you execute HTML code, all right? So the HTML code calls a particular class that says, okay, this sticker is in this particular folder, and go source it and put one next to the other and write a line to the top of the screen. That's what the CSS code is, right? I just stole it. I had to unpack it to learn what's going on. It didn't work the first time, so I had to nudge it a little bit to make it work for my computer, my screen, whatever.
That was pretty cool.
Did you have to download the hex images?
I went to
for each
Google.
package that
I went to Google and I found each package and I saved it. And of course, in Max Kuhn's repository, he has all the tidyverse and the tidy models, right? He's got those stickers in there in his repo. I had to go to Google Images pick up.
very
So
I have a couple of questions. Well, I have a quick question. When I was on the phone, I heard you say something about some date manipulations that you were doing in one of those new packages, one of those two packages. Are there a lot of overlap between the three packages that you demoed today and some traditional, some already existing tidyverse packages? Like, because when I was thinking of date, I was thinking that okay, you'll use lubricate for that, but
correct. And year quarter is not in lubricate.
Okay.
And year month is not there, but you can use the YM function in lubricate, right? YMD, year, or even as date month, right? This is extended the Sybil package has extended that feature.
Okay, good. Okay.
And because earlier I showed in base time series stats package, which has got the TS object, right? There, if you plug in, if you did this, oh, it's still running. Dang it. Let me see if I see here. Not sure if you're still able to see my screen here. TS, and I said make 10 vector of size 10, frequency 4, start of 2020 January. It automatically made a quarter 1, quarter 2, 3, and 4. See, this is the base R, right? It was smart enough. So I think felt compelled to do that. You know, fit benchmark. So all the 304 individual time series, I have models for those. I use it at work. This, plop in a bunch of different models and go away, come back after a shower, it's ready. I have several accounts that are different warehouses, and I have time series for different work types in a warehouse, right? And different locations of warehouses. So if I need to benchmark my forecast of orders, what I typically do is have about 8 or 9 models that I use. Plop it in, go for a shower, come back, it's ready. So that is something that's been super. Again, it's not all rosy. Again, this package is still under development. They are changing it. You can see some of the circuses that I had to do and jump through certain hoops just using the Fable package for certain nuances. If I want to combine 2 different models, say for instance, I fit in a linear regression model, but I want to knock out the intercept and plop in my own intercept to it, right? So a time series can be decomposed into level, trend, cycle, seasonality, and the remainder, right? If I want to play around with the level, then I can, insert a level parameter and ignore the model's level parameter. I can do something like this. I have attempted to do that there. And mix 2 different models, not just ensemble, get the level from a different model, get the seasonality parameter from a different model, and then, make a composite model. And I can call that model composite. And just like how, just like how you have the different models being named Arima, ETS, and Season Life, you have the composite model, whatever that you name it, that'll show up. You can affect the legend as well. So those things can be done.
Out of curiosity, what would make you want to use, give me a situation where you would want to use the seasonality from one model, as a proxy for the seasonality in another?
If let's take Arima, for instance, right? Arima has 3 parameters for explaining the trend, 3 parameters for explaining the seasonality, right? Which is the lag, the differencing to make the time series stationary, and your Fourier model could capture the seasonality much better in some cases than the Arima model, right? So you take the trend component from the Arima model, trend explanation, the lowercase PDQ, have it on one hand. On the other hand, use the Fourier series to explain the seasonality, put them together, right? Okay. Which is what I've tried to show here. Right here. So yeah, I'm forcing the seasonality to be 0, 0, 0. So I'm telling Arima, don't do anything with the seasonality right here. Get all the seasonal power or explanation from the Fourier models, right? I use one basis model, or one basis spline, or one basis frequency, right? And to 6 basis frequency to explain the seasonality, right? So you use 6 different curves with 6 different frequencies, all add up and somehow fits my seasonality better, right? So in this case, that has got the lowest AKI criteria. And you can see all the, you don't see any PDQ, uppercase PDQ here, right? It's a linear regression model with ARIMA errors, but with Fourier parameters, which gives you all the nice wiggliness to be able to model that. Have I answered your question?
Yeah, you did perfectly. Yeah.
Okay.
I thought I was gonna be able to stump you, but you answered that question perfectly.
Oh, yeah, that's what I think. The Fable package is much more transparent in what you can do with it.
Yeah.
So that's what I like about it.
So would you say the package is buggy? Is that how you classify it?
I would say it is buggy, to be honest. After checking all my code yesterday, and I had end on the entire project, then I wanted to install Forecast package just to compare Forecast and Fable's behavior for this meeting, right? Once I installed Forecast, boom, it broke everything, right? So, and I couldn't figure out what was causing the problem. And I got out of RN, tried a different project altogether, it broke. I was telling Arvind, who's on the call here today, I do not know what I did. It magically came back, right? I honest to God, I can't recall what I did, okay? Except for Fable tools that I installed from GitHub. It's still the same version, and what's on CRAN and what's on GitHub, the same version. But I can't explain why it is. So anything that is Fable, I RN with. So DKO to you. So makes my life a little bit easier.
Now, is that like similar to like environment? Is that like our versions of environments?
Correct me if I'm wrong, DK. So it is like Packrat. I'm not sure if you're familiar with Packrat. Packrat basically stores takes your tar files of all your packages and saves it for that particular project, right? And you bundle them all up and you give it to someone for them to execute, right? So they kind of install the same versions of packages that you have. The RN is nothing but same syntax, everything same like Packrat, except that you're not making tar files and all those stuff. It's just basically like a text file, like a log file that has got links to all the different versions of the packages. This has got the hashtags for all those packages, so it asks the user to install that version for that particular project alone.
Right. I was trying to see how they compare to Conda environments in Python. Like in Conda environments, not only can you specify the version of the Python library, but you can also specify the version of Python. So is that similar to what we're talking about right now? You can specify both the version of R and the version of the packages that you're using, or is it not that?
I'll defer that to DK.
Yeah, I think inside of the RM flock file, it will say like what version you are originally using, but it won't. I don't think it will restrict you to using that version, because like I have a project that I'm working on and I created an RN R environment for it, but then I upgraded my version of R, and I think when it so at that point, I think it went and downloaded or recompiled all the packages and reinstalled them into a new environment for that version of R that I was using. But every time I open up the project, it reminds me that my original lock file was using a.
Okay.
So
if I want to learn more about this, I Google this RN. What do I need to Google?
Yeah, go on to I think there's a my guess is that there's a nice page on, I want to say if you go to like rm.rstudio.com, it might be there. But I think I'm pretty sure we recorded a video of that, and it might be up on our group's YouTube page as well. So
Yeah.
but there's actually where I heard about it was from the RStudio conference. There was a presentation about it at the RStudio conference. So I feel like that's a great like introduction to how to get started with it.
Okay.
Right.
RENV. Okay.
Yeah, RENV.
Yeah. So
That's
it's
great.
in our studio GitHub as well. So.
But I think it's it falls in line with the trend of uh, a lot of languages. What they have is that lock file that says here's the version of the language you originally built this with. Here are the versions of the packages that you used, and here are some hash usually there's some kind of like SHA-250 hashes of the package to make sure that you're actually installing the correct version of the package, and the package that you download matches the package that the person who originally installed it was using. You know, so behind the scenes, I think RENV is it does some package caching stuff for you on your machine. So let's say you had two different projects and both of them were using the same version of like some package, then if you had already built that package for the first project and now a second project is saying, I need that package too, then it doesn't have to go through and rebuild the package. It will just grab it from its package cache that it has locally. So.
Yes.
One of the things that I like about this Fable is the approach to hierarchical modeling. I do that at work today. So if you have like a region and different states, and within different states there are different warehouses, and within warehouses there are different operations, kind of nested like a hierarchy. This can set up the data as a hierarchy by itself, and it can optimize the forecast such that the forecast can add up to the aggregate forecast. The hierarchical time series package, HTS package, is really cumbersome to execute some kind of hierarchical models. Right? There are different kinds and different kind of nesting. Some are really difficult to set it up. Fable has a good way of doing it, and I use it at work.